Good day, Algebra 1. I'm going to do the Unit 7 test review for tomorrow's test on Tuesday. This will help you go through the rest of the review. Just remember, we completed most of this in class. I did not complete the last half, so if you did not get that, make sure you go through those notes at the end. But I'm basically going to do what I just did in class and kind of go a little faster, okay? All right, so first thing we need to do on this first problem is complete the table below for the quadratic equation shown below. Use the table to make a graph, then state the properties of the graph. So first let's complete the table, then we're going to graph it, and then we're going to have to figure out all this information over here on the right. Okay, so first things first, let's plug in this -2 into the equation. The way I'm going to do that is I'm going to use my calculator. So let me show you how I'm going to do that. So I'm going to go to my calculator here. The first thing I got to plug in is -2. So I get -2 squared, and then the equation says -4. So whatever I have, wherever I plug in a number, put parentheses, and then add 3. So -4 times -2 plus 3. There's my first value, 15. 15. Okay. Then I'm going to go up, change the value to -1. And I get 8. And so I'm going to go through and do that with all the points. And as I do that, as I did in class, I will have 8. And then the next number I will have is going to be 3, 0, -1, and then it's going to repeat itself, 0, and then 3 again. And what you should notice this time is that that value that's in the middle, our vertex, is not in the middle of the table. It's right here. It's actually kind of towards the bottom. Because you assume, oh, well, the 1 and 0, that must be the vertex, right? Because it's coming towards the middle. But it might not be. It's the middle of your data. And if you notice, it goes 15, 18, 3, 0, -1, 0, 3. So here is the middle, okay? Because it goes 0, -1, 0. Okay, that's where it is the same, or it repeats. It's mismo, okay? So that's your vertex, but let's draw the graph first. Now, first of all, -2 and 15. That doesn't fit on the graph, so don't graph it. Go to the next point. -1 and 8, I could kind of graph it. It's not totally on the graph, but it's not too far from it. Then 0, 3. Then 1 and 0. Then 2 and -1. Then 3 and 0. Then 4 and 3. Okay, then I'll go ahead and make my U. And now we need to fill in the rest of the points over here. Okay, so the first thing is the vertex. Vertex, get that from two places. We can get it from here on the graph, point in the middle, or we can look over here on the table. And we know that point is to -1. Line of symmetry. Okay, line of symmetry. Oh no, where'd my pink color go? There's my pink. Okay, so now pink, remember, pink. Line of symmetry is the line that goes straight through the middle of your graph, and that is described by an equation, and that equation is x equals, and it's the same value that it passes through, the 2, which also comes from the vertex, that 2, same 2 there. Okay, now the x-intercepts. Okay, we're looking for where does it cross the x-axis. Well, it crosses here, and also, well, first of all, you see that that's 1 and that's 3, and also you see that same 1 and 3 over here in the table. Okay, because we know that wherever y is 0, that's also an x-intercept. So I'm going to include that over here. So we have 1, 0. And 3, 0. All right, now the y-intercept. Okay, the y-intercept is where it crosses the y-axis there, and x is 0 on the y-intercept, so that means that would be this value, 0, 3. And you can also see that by just looking at the graph. Okay, next question. Does it have a maximum? No, because it goes up. There's no top to it. It keeps on going up forever. But there is a bottom. So that means we do have a minimum. And the question is, where is that minimum? Well, the minimum is the same as the y value of the vertex. So -1 and so -1. Okay. And the last questions are domain and range. Okay, so for domain, we always start with brackets. It goes to the left forever and ever, goes to the right forever and ever. So we know all real numbers, and it's always the same for domain. For the quadratics, it's always going to be all real numbers. Okay, so now for the range is y, or the y values, and y is going to be greater than or equal. And it's greater than or equal because, it's greater than because the graph is going up, and it's going to be greater than the y value of our vertex, which is the bottom of the graph. Okay? All right, next one. Okay, so now this one. You are going to draw quick sketches of this graph, but first, before we do that, we're going to come up with the vertex and figure out how many x-intercepts does it have. So first, these are all in vertex form. Okay? This one's not as obvious, B, but we can put it in vertex form, and I'll show you how to do that. Okay, so first of all, remember the vertex comes from the number inside the parentheses and the number on the outside. X is the liar, so this -5 is a +5. But the 1 is not next to x, so it's not lying to you. It's still +1. Okay, so graph that. 5. Oops, sorry. And there it goes. And this graph, looking at the a value, -3/4, if it's negative, that means we're going up. So then the graph simply points up. And go ahead and label that A. And so if it's pointing, oh, I apologize, it's not pointing up, it's pointing down because it's negative. It's negative, so it's going down. So if it's going down, that means it crosses the x-axis at 2 points. So it has 2 x-intercepts. So that's the question. Not what are the x-intercepts, but how many are there? Okay? Now this one is not as obvious. But to find the vertex, remember that this is also the same thing as 5 times x plus 0. So if there's no parentheses there, then you can put x plus 0 and then still -3. And now you know the vertex is 0 and -3. So go ahead and plot that point. 0, -3 there. Forgot this was A. Let's label that A, so remember that. And 5 is positive, so that means we're going to be going up. Up. Okay, and if we're going up, that means we're going to cross the x-axis twice, here and here, so we have 2 x-intercepts. Okay, so now the last one. Again, x is a liar, so not -2, but +2. And then the last number goes here, 6. Let's plot that. 2 and 6 up here. And A is positive. Remember, A is 1 in this case since there's nothing there. So that means it's going up. And if it's going up and it's above the x-axis, that means it never crosses. So that means there's none. Okay, next page. Now this one, first thing you want to do, well, what we want to do, or what we have to do, is figure out the missing figures. Okay, so this is figure 1, 2, 3, 4, 5. In this case, we're also going to need to figure out figure 0. Okay, so I know, looking at all these, that the part that is the same is this bottom portion, these 4 blocks. Okay, and it seems like we're growing a square onto the top. So if that's the case, then I know that all of these are going to have 4 blocks. So I can just go ahead and fill this in. I know these all will have 4 blocks. But now I've got to figure out what's on top. Okay, well, let's do that by first finding out how many are in each figure for the ones that we do know. So this has 8, I counted them. And then I counted here, I had 13. And when I counted here, I had 20. And the question is, going from figure to figure, how many are we adding? Or how much is it increasing by? Well, here we're increasing by 5. Here we increase by 7. So that means most likely we're going to increase on the next one by 9, because it seems to be increasing by odd numbers. So then that means this would have had to have been plus 3, and this one would have had to have been plus 1. And that'll help us figure out how many blocks we should have in our missing figures. Well, if this is plus 3, then what plus 3 equals 8? Well, that'd be 5 plus 3 equals 8. So that means figure 1 had 5. And then what plus 1 equals 4? Equals 5. That'd be 4. So that means figure 0 had 4 tiles. So it looks like figure 4 we're good to go, because it has 4 tiles, and it's supposed to have 4 tiles, and that's what we have. So we're good. But here we have 5. So it means one more. So the question is, where do we put that one block? Do we put it on the first block, second block, third block, or fourth? Well, let's look at our pattern. Let's look and see how it's growing. If you notice, it starts here with this 2 by 2, and then more blocks get added to the top and the left. And then here, again, more blocks get added to the top and the left. So it's almost like it's moving to the left. So that means it must have started, if it's moving to the left, that means it started on the right. And you notice that there's one block that's not touched here, this last block. So it can't be the fourth block. We know that. So that means we must have started here over the third block in order to go from this one to this one, because we moved left from the third block to make a 2 by 2. Okay? So then here, we're going to make our box. And I know that this is a 1 by 1. This is a 2 by 2 because it's figure 2. This is a 3 by 3 because it's figure 3. This is a 4 by 4 because it's figure 4. And so that must mean that this is a 5 by 5 because it's figure 5. So make your 5 by 5 shape, and there you go. Okay, so now let's fill in the table. Figure 0, we have 4. Figure 1, 5. Figure 8, 8. Sorry, figure 2, 8. Figure 3, 13. Figure 4, 20. Figure 5, well, what is figure 5? Well, it's 20 plus 29, and 5 by 5 is 25, plus 4 is 29. So yeah, 29. Well, what's next? Well, let's look at our pattern again. Again, we had plus 1, then plus 3, then plus 5, then plus 7, then plus 9. So that's plus 9. Then that must mean this is plus 11 and plus 13. So then 11 plus 29, 40. 40 plus 13, 53. So there's the rest of our table. Okay, so we finished the table. So now what we need to do here on C is we got to draw a sketch of figure 100. Okay, and you guys remember these. Remember that, first of all, we know that we're going to have those 4 blocks, just like we did before, because they're always going to be in every figure. So we'll first draw those 4 blocks. And then we're going to have a square on top. And if you notice, my little sketch is not perfect at all, because I don't expect perfection. Okay. What I do want to know is your square that you make. Well, what are the dimensions of it? What by what? And in this case, we know that it's going to be 100 by 100, because every figure, going back up to these examples, figure 2 has a 2 by 2 on the top. Figure 3 has a 3 by 3. Figure 4 has a 4 by 4. Again, 3 by 3, 2 by 2. And figure 5 has 5 by 5. So that means figure 100 will have a 100 by 100. And then we need to figure out the total. Okay, so the question is how many total? And the total would come from 100, one side times the other of the square. And then again we add that 4. So then 100 times 100 is 10,000. And then don't forget the 4 again. And then equals 10,000 plus 4. So 10,000 plus 4 is 10,004. Hey, look, there's the 4 again. It didn't go anywhere. And I say that because I don't want you to forget about the 4. Okay, now we want to create a function. All right, well, if you notice here, going back to the table, they gave us a title for the function, because usually you say y equals or f of x equals, but look, going back here on the table, number of tiles is t of n. So we want to use the same variables they're using. So if it's t of n, then I'm going to start it with t of n. So t of n is equal to, and the variable we're going to use is n, which represents the figure number. And to get the total, this 10,004, I had to multiply one side by the other and then add 4. Well, where did I get this number 100 from? That became from the figure number, n. N times n. So, n times n, and then, don't forget, add the 4. Okay, I say over and over again, don't forget that 4. All right. So now, simplify that, and t of n is equal to n times n, which is n squared. And there is your function. Okay? So now go down here. Okay, now you're going to find the vertex, find the x-intercepts, and also the line of symmetry. And you're going to make a sketch. So first let's find the vertex of this vertex form quadratic. And the nice thing about vertex form is that the vertex is right there for you. So if this is positive 1, then this is negative 1. This is negative 8. This is still negative 8, because my x is a liar. So if it's next to x, it's lying. It's positive here, it's negative here. But if it's not next to x, it's still the same. Negative 8, negative 8. Okay, so now line of symmetry. Well, I know if I know the vertex, then I know the line of symmetry, because the line of symmetry comes from the vertex. Or it's the same as the x value of the vertex, so x equals negative 1. So let's go ahead and graph that. So x equals negative 1, and you can graph either one first, doesn't matter. And then negative 1, negative 8, so that would be down here. And now the next thing I need to find is the x-intercepts. Okay, so let's remember that for x-intercepts, wherever they cross this x-axis, that the y value is going to be 0. Because along this axis, the y value is always 0. So that means to solve for the x-intercept, I can just plug in the 0. Okay, so let's write these x-intercepts here as points on the side. Because remember that the y is 0, so then we're just plug in 0 to find the rest. Remember, because if I know one value, if I know x or y, then I can just plug in that number and find the rest. Okay, so now we're going to add 8 here first. We're going to add that number on the outside, cancel it out, and then we get this, 8 equals 2 times x plus 1 squared. And then we don't want that 2 here, so let's divide it from both sides. And we want to divide, not subtract, because we're multiplying 2 here. And when you multiply, you have to divide to get rid of it. But here we added the 8 because we're subtracting. If you're subtracting or adding, you're going to add or subtract. If you're multiplying, you're going to have to divide. So now 4 is equal to 2. Sorry, not 2, because the 2 went away. Canceled out. Now 4 is equal to x plus 1 squared. And as you remember, when we get to this point, we're going to square root both sides. Once we have a number on one side, parentheses squared on the other. And when we square root a number like 4, it's both plus and minus the square root of 4, which is 2. And then the parentheses on the other side go away. And then we want to subtract this 1 to get x by itself. And now let's figure out what our solutions are. There are zeros. Positive 2 minus 1, 1. And then the next answer will be negative 2 minus 1, negative 3. And go ahead and plot those points. So we now have 1 and negative 3 for x-intercepts. And then we'll go up to the graph, negative 3 here, and 1 here. And that's all we need to finish our graph. Some of you might ask, well, what about the y-intercept? And in this case, we're just looking for a quick sketch, so we're not going to make it perfect. So if you don't have the y-intercept, that's okay. Not necessary. Okay, so now the domain. What's the domain of any parabola? all real numbers. We know that. Okay, range. You notice I'm putting it down here because it's not enough room to write this in. Range, remember, is always y, and if it's pointing up, it's going up, it's going to be greater than or equal. And where does it stop at? On the bottom. Well, it stops at -8. And that -8, again, came from our vertex, or the y value of our vertex. So it's going to be -8. And now, how about the maximum? What is it? Well, there is no maximum. There's no top to our graph. So there's none. And how about the minimum? Minimum is the bottom of the graph, and there is a bottom. And we want to know the y value at the bottom, and that y value is -8. Hey, guess what? Same -8 that came from the vertex, and we used it in the range. Okay? Next page. So now on this page, you are going to have to, or for number 5, you're going to have to match each of these graphs to the correct equation or function. So, first thing you want to do is you want to find the x-intercepts and match them up. Okay, so this first one, remember that x minus 6 squared is actually the same thing as x minus 6 multiplied 2 times. So I'll rewrite it that way. So then the x-intercept for this equation should be x equals 6. And it's only 6 because x minus 6, the x-intercept is 6, and x minus 6 again, so that means it's the same thing. So, and again, then the next thing we want to do is look at the a, the number in the front. And the number in the front tells us that it points up, and we know the x-intercept is 6, so which one points up and only has one x-intercept at 6? That'd be this one, C. Okay, so then we write C here. Okay, now the next one, let's find the x-intercepts. Well, we know that x is the liar, so this is not -2, but +2. And the next one would be -6, not +6. And the last thing is that the a is -2. So if a is -2, that means it's going to point down. So the question is, which graph is pointing down? Well, that would be this one. And the x-intercepts are at 2 and -6. So that means that this next one is D. Okay? So we're left with 2 more graphs to figure out. So once we figure out one, then we know the other. Okay, so now again, look at the x-intercepts. Here the x-intercepts are going to be, this is -2, so +2. This is +6, so -6. And then we look at our a value, which is 3. And 3 tells us that it goes up. So which graph has those same x values, or x-intercepts, but then goes up? Right here, 2 and -6, and it's pointing up. So then A. Okay, so now, let's put the same color, A. So we know the last one, of course, is going to be B, but let's just make sure we see Y. Okay, so x-intercepts are going to be, well, the first one I'm going to look inside the parentheses, and x is a liar, so not -6, but +6. And then out here, it's not in parentheses, it's 3 times x, so what would I plug into x to make it 0? Just 0. Okay, and the a value is 3, so it must point up. So which one points? So you know that this one points up, and the x-intercepts are at 0 and 6. Okay? Okay, so now number 6. Find the following information about each equation. Okay, well, we want to know the vertex, so let's put this into something that looks more like vertex form. So just like, let me go back here to this one on the first page, letter B. This didn't look like it was in vertex form, so I changed it to x plus 0. I changed that x to x plus 0, so I'm going to do the same thing with this one we're looking at on that third page. Let's go back. So what I can change this to is 9 times x plus 0 squared minus 4. Now I can just look at that equation and see that my vertex is at 0 and -4. Alright, But now I need to figure out, well, what are my x-intercepts? Okay, well, I'm going to have to solve that. And remember, I know that for my x-intercepts, that my y is 0. So plug in 0 for y. So now I have 9x squared minus 4. And now there's a few different ways you can solve this. You can use square roots. You can do the x box. Or if you recognize that this has two numbers with a minus in the middle, I can take the square root of both sides. I'm sorry, of both numbers. So I take the square root, and this is, remember, it's called the shortcut. So now square root of both. And the first number is going to be the square root of the first number, which is 3x. So that goes here and here. And then the second number is going to be square root of the second one, which is 2. And that goes here and here. And then the signs are going to be positive and negative. So now our answer is going to be negative, because this is positive. And remember, when we have a number in front of the x, that means that this number goes first, 2, and then we're going to put that over the first number, 3. And the same thing here. Well, except this is negative, so this one's going to be positive, and then the 2 goes first, and then over the 3. So then we have negative 2 over 3 and 0, and positive 2 over 3 and 0. Okay? Let me show you one more example just like that, though. What if I had y equals 9, sorry, not 9. What if I had y equals 4x squared plus 9? Well, okay. Plus 9, let's change that to 4 times x plus 0 squared plus 9. What's the vertex? Well, I know the vertex is 0 and 9. And then which direction is this pointing up? Because the second question I'm going to ask you is, well, what is the what are the x-intercepts, right? Okay, well, let's think about this. Let's graph it. If the vertex is at 0, 9, so that's up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and the graph points up, do we have any x-intercepts? No, we don't. There's none. No x-intercepts. And remember when you were solving the quadratic equation before, and you get a negative inside the square root? That's what would happen here as well. Okay, so then you would, it was also, you could say, no real solution. Okay, so there's no real answer. There actually is an answer, but it's not a real one. Okay, it's a different kind of answer called imaginary. Okay, so be on the lookout for that. That might happen on the test. Okay, where there's no x-intercepts. All right. Okay, so now here, the vertex, well, the vertex is not as obvious, but what I can do is I can use this little formula, x equals negative b over 2a. You guys remember that? And the vertex, the x value for the vertex is going to be negative b. Well, b is negative 6, so negative times negative 6 over 2 times the a, which is negative 1. Okay, let's do this one step at a time. So negative times negative 6 would be positive 6. And then 2 times negative 1 would be negative 2. And so x is equal to negative 3. Okay. So then our x value is negative 3, but then we've got to find our y value. And we're going to have to plug that negative 3 into the equation to find it. Because remember, this is not vertex form like the last one. I can't put this in vertex form. Okay, it's not the same. Because I have this middle number. When you don't have a middle number, like here, you can just go ahead and make this x plus 0 times the first number. Okay, but if you do have a middle number, then you're going to have to use this formula to figure it out. Okay, so now y is equal to negative 3 squared minus 6 times negative 3 minus 5. And then we have 9. Negative 3 squared is 9. And then negative 6 times negative 3 is positive 18 minus 5. So then 9 plus 18 is 27 minus 5. Well, that's going to be 22. Okay? So now this graph is at 3 and 22. That's above the x-axis. Something like 1, 2, 3, and something way up here. But it does point down, so we are going to have some x-intercepts here. Okay, so we're going to have to solve that equation, or that function. So first of all, we know we're going to have to set it equal to 0, because y is always 0. And the problem is with this function is that the first term is negative, and I cannot have the first term in front of x squared be negative. So in order to get rid of that negative, I'm going to divide everything by -1, because it's -1 in front of the x squared. Divide everything by -1. Now I have x0 divided by -1 is 0. -1x squared divided by -1 is positive x squared. Then -6 divided by -1 becomes positive 6x. And then -5 divided by -1 becomes positive 5. Now I can simply just use my x. 5 on the top, 6 on the bottom. My numbers are 5 and 1. So now 0 equal to x plus 5, x plus 1. And I know x is a liar, so I'll have -5 and -1. And there we go. Okay, so it takes a few steps to solve this one. Okay, it's probably the most steps out of any of the problems in this test that you'll have. Okay, so now the last couple here, our last problem, number 7. We're going to use this equation, and we're going to find the vertex using two different methods. Okay, so first of all, what should be true about both answers? Well, I think we all know that they should be the same, right? Okay, so let's use the zero product. That means we're going to use the x. So -12 over 4. And why are we going to use this? Because once we find the x-intercepts, wherever they are, we know that the vertex, the x value, is right in the middle. Okay, so we're looking for those x-intercepts right now. So these numbers, I think they're going to be 6 and 2. And it has to be positive 4, so that means the bigger number has to be positive. So then I'll have x plus 6 and x minus 2. So that means my x-intercepts will be at -6 and positive 2. And the number that's the middle of -6 and 2, well, -6 is over here. 1, 2, 3, 4, 5, 6, and 1, 2. Here's -6. Here's 2. And then I got to figure out where that middle point is. Let's see, the middle looks like it's right here at -2. Okay, because it's 3 to the left to get to -6 and 3 to the right to get to positive 2. So there's our x value for a vertex, because remember, I drew the line of symmetry, but then we know the x value of the vertex is the line of symmetry value, so -2. So now we just need to find the y value. We have x value, so find the y value by plugging it in. So now y is equal to -2 squared plus 4 times -2 minus 12. Okay, so now we have 4, then 4 times -2 is -8, minus 12. 4 minus 8 is -4, minus 12 is -16. Okay, so our vertex here is -16. Okay, and we had to do that by finding the middle of the x-intercept. That told us the x value, and then we had to plug in that x value to find the y. And now the formula. Okay, remember the formula, simply x equals -b over 2a. So plug in negative times the b is 4, and then over 2 times the a is just 1 in this case. So then we get -4 over 2, and that's going to be equal to -2. And then I do the same thing again. I plug in the 2 into the equation. And some of you guys might be like, oh, well, that was so much easier, right? Well, all you got to do is just remember that formula, okay? You're going to need to know the formula in order to do this question on the test, okay? So now Negative 2, I plug it in, and I know that I'll get negative 16. Okay? Now this last one. Last one, I simply just need to find, does this point land on this graph? And I'm going to figure that out by simply plugging in those points. Here's my x, here's my y. Plug it in for the x here, here, and for the y there. So 85 equals 4x, not 4x, 4 times the x, which is negative 4 squared, minus 2 times the same x, and then plus 13. So now 85 is equal to 4, and then times negative 4 squared is going to be 16. Negative 2 times negative 4 is positive 8, plus 13. And then 4 times 16, well, that's going to be 64. 8 plus 13, that's going to be 21. And then 85, the 64 plus 21 is 85. So yes, this is a solution because it is equal there at the end. Okay? Have any more questions? Come and see me. Send me a message or a mine. I'll see you guys tomorrow. Good luck.